Although applying to only a select few compounds, hydrogen bonds are extremely important, providing the basis for why water can support life, the structure of proteins, and even the existence of our DNA. A hydrogen bond forms when a hydrogen bonded to a very electronegative element bonds to another electronegative element. What makes hydrogen bonds special is that unlike ionic or covalent bonds, which are more permanent, hydrogen bonds are constantly being broken and reformed. This property is also due to the fact that, generally, hydrogen bonds are much weaker than covalent or ionic bonds, having 1/10 the strength of covalent bonds and even less strength compared to ionic bonds. The order of strength for bonds can typically be listed as hydrogen, covalent, ionic, when writing them in order of weakest to strongest. As stated, a hydrogen bond exists between a hydrogen bonded to a very electronegative element and another electronegative element. The general rule is that these very electronegative elements are either nitrogen, oxygen, or fluorine. Looking at a periodic table of electronegativity, it is easy to see why this is the case. Although hydrogen bonds can exist with other elements, such as sulfur and chlorine, this is really not common. And for the purpose of your chemistry class, it is simplest to allow the existence of hydrogen bonds to fall only within these main three elements. Again, those being nitrogen, oxygen, and fluorine. Let's now draw one of the most apparent examples of hydrogen bonding, that between water molecules. I have here three water molecules, and I will now draw a hydrogen bond from this outer hydrogen to this oxygen molecule. Notice that after drawing this bond, this water molecule still has its four owned electrons. Remember, this is why hydrogen bonds are constantly forming and breaking. We can also draw a hydrogen bond from this hydrogen molecule to this oxygen molecule. In fact, each oxygen molecule can have up to two hydrogen bonds. This is one of the reasons why the boiling point of water is so high. It is also very likely that in your chemistry class you will come across a question similar to this one. Which diagram best displays a hydrogen bond? The bond being denoted by a dashed red line. To answer this question, just remember that a hydrogen bond exists when a hydrogen bonded to either nitrogen, oxygen, or fluorine then bonds to another nitrogen, oxygen, or fluorine atom. Keeping this in mind, we know that A is incorrect because the hydrogen is bonded to a carbon. B is incorrect because the hydrogen is bonded to a chlorine. And C is incorrect because the hydrogen is both bonded to a hydrogen and forming a hydrogen bond with a chlorine. D is correct because the hydrogen is bonded to an oxygen and is forming a hydrogen bond with nitrogen. Again, to ensure that you always get these questions correct, remember NOF, NOF. Returning to our example of water, the hydrogen bonding between water is an example of intermolecular force. This is when the bond exists between one molecule and another separate molecule. Hydrogen bonding can also exist intramolecularly. This is when hydrogen bonds exist within a compound. This can best be seen through the molecule salicylic acid. Due to the geometry of salicylic acid, an intramolecular hydrogen bond can form between this hydrogen and this oxygen. I have this example including salicylic acid just to show you the difference between inter and intramolecular hydrogen bonding. However, I'd like to emphasize that in your chemistry class you will predominantly be dealing with intermolecular hydrogen bonding, mainly because they're just so much more common. I hope that this video has given you a better understanding of hydrogen bonds. Thank you.